In finding domains of functions, there's a couple things we're really going to be concerned about and watching out for, and those are first fractions and then square roots. For fractions, what we're going to worry about is the denominator being 0, because that would be equivalent to dividing by 0, which is undefined. So we don't want to let that happen. With square roots, we're worried about taking square roots of negatives, so we need the expression that's underneath that square root sign to be greater than or equal to 0. So we would take the expression, set it greater or equal to 0, and solve. All right, let's take a look at a fraction example. In this case, I have a big, ugly function, h of x equals that there, and I really don't care what the top is. I'm really just worried about this bottom part. I don't want my denominator of my fraction to be 0. Okay, so I got to figure out what's going to make this equal to 0, and then we're going to exclude that. So I take this, I set it equal to 0. Now, because it's an x squared and not just simply x, I can't get x's on one side, numbers on the other. We're going to solve by factoring or unfoiling in this case. So x times x would give me my x squared. A positive times a negative would give us a negative 3. And if I check my outer, negative 1x plus 3x, yes, that's going to give me my 2x in the middle. Now, if I have something times something is 0, that means either this first part, x plus 3, has to be 0, or this second thing, x minus 1, has to be 0. Solve each of those two simple equations, and then we come up with a negative 3 and a 1. So those are the things we want to exclude. I can say in words that my domain is all reals except negative 3 and 1, or I can use what we call set builder notation, and I would use this little curly bracket, and that's the set of x. This vertical line we read such that x is not equal to negative 3, x is not equal to 1. Now what if we're given a graph, a visual? I want to be able to define and figure out what the domain and range are looking at this one. And this is the square root of x plus 4. So we know there's going to be a limitation on our domain, right? Because we need this part under here to stay greater than or equal to 0. Right? But let's take a look just by looking at the picture instead of doing it algebraically. The domain corresponds to my x values, right? What part of this x-axis associates with the actual graph? Well, I don't see any graph way back here anywhere. I don't see any graph until we get to this point, negative 4 on the x-axis. And then I see the graph all along here, all along here. Does it stop at 5? No, this arrow says it goes forever into the direction, into the right direction, so that would go to infinity. So when I write down my domain here in interval notation, I use a square bracket to show I include that negative 4, and it goes to infinity. We never use a bracket with the infinity, we just use a parentheses. Now what about the range? Well, the range is the y value, so you kind of tilt your head sideways, and we always start in numeric order. So we start way down here. There is absolutely no graph down here. The graph doesn't start until you get right at this level, which corresponds to y equals 0. So we're going to begin seeing the graph at y equals 0. We see the graph, we see the graph. Now the graph doesn't stop here, right, just because it crosses at 2. This arrow is indicating it's not only going to the right, it's going up as well. So my range would go from the 0 all the way up as high as we can go. And we would express that as the interval 0 with the bracket to infinity, again with the parentheses.